Hi, I'm Jeff Weisenberger, Editor-in-Chief of Modern Steel Construction, the monthly magazine of AISC. I'm here at NESCC, the Steel Conference in Denver, and I am talking with Alan Adams, who is one of our Lifetime Achievement Award winners this year. Congratulations, Alan.
Thank you. Thank you.
A quick note on the awards. The Lifetime Achievement Awards honor folks who have made a difference in the success of AISC and the steel industry at large. Alan is the Chief Structural Engineer with Bentley, and he's being recognized for his contribution to the development of ramp structural systems, his drive to improve the accuracy and speed at which steel buildings can be designed, and as well as his service on multiple AISC committees. So again, thank you, Alan, for being here. Since we're at NESCC, I have to ask, how many steel conferences have you been to?
I've lost track, but I think it's probably in the range of 25.
Okay.
Probably around 25.
Sure. Well, that's a pretty good amount. I have to ask, are any of them sort of stuck out in particular, or they all kind of bleed together at this point?
They sort of bleed together, but over time they've just gotten better and better. And I really enjoy being at them. They're so much fun. There's so much to learn. There's so much to see. I like the connections that I've made over the years, and then to see those connections over and over again. Yeah. So of all of the trade shows I go to, I have to admit this is the one for me that's most satisfying and the most fun.
Oh, well, that's very good to hear. Yeah. So let's talk a little bit about RAM then. So where to begin, I suppose? Can you talk a little bit about how you got into developing the program? Did you start as a structural engineer, or did you have a software background?
So I started work for an engineering company called Copeland Tanner Structural Engineers back in 1983. It was in Northern California, and while I was at Copeland Tanner, I did structural engineering. We did a lot of parking garages, hotels, casinos, office buildings, and think about the 1980s, that was before PCs. Mm-hmm. The state of engineering software was very rudimentary, and so a lot of what we did was by hand. Design charts and things by hand, and I was fortunate that at Copeland Tanner, they were forward-thinking enough that they actually had a computer there in-house. It was called a mini computer, and it was called a mini computer because it didn't fill up a whole room like a regular mainframe computer, but the mini computer was the size of a large filing cabinet.
So mini.
Yeah, and there were no graphics, there was no graphical user interface, and so we wrote some rudimentary programs that we used there. But we were always talking, wouldn't it be nice if we had a program that did all the bookkeeping, did all the number crunching, did all of the stuff that requires an engineer to know how to do it, but doesn't really allow the engineer to be an engineer. Mm-hmm. To make his project better, because if with a tool you can do all the number crunching stuff, mm-hmm. and then you can be an engineer and make your project better by using your engineering. And we would talk about, wouldn't it be nice if we had that, and the more and more we talked about it, we decided, well, there's nothing out there, we can do that. Okay. So we had a programmer that was taking care of our programming system, and he'd gone on to another company, but we brought him back. I was an employee at Copeland Tanner. I was given the assignment to work with the programmer to create what we now know as ramp structural system. Okay. So this was in 1988. Okay. So I had about 5 years of engineering experience. In 1988, I started working with Mike, and he was the programmer, I was the engineer, and I would tell him this is what we need in the program, and he would go off and work on the program. I'd go back to my projects, designing buildings, and then if he needed something, I'd go back and I was working with him. I had enough programming experience that sometimes it was just easier for me to program engineering equations like code equations than it was to tell him what to do. So I actually contributed to the programming part of it. And for the next 2 years, it was the two of us mostly with a couple of his friends that were programmers that helped with some components. But in 1990, we released the first version, which we called RAM Steel.
Right.
And all it did was gravity beams. And then a couple of months later, we released the column design module.
Okay.
So this was in 1990. Along the way, we implemented frame analysis, so you could do wind and seismic, not just gravity, and added foundation design. And then in 2005, Bentley Systems came along and they acquired the company. So RAM International became part of Bentley.
Right.
And we retained the RAM name on our products because we were so well known. And so we're now part of Bentley, and that was in 2005. So Bentley has a wide range of software products, anything to do with infrastructure, construction management, project management, water, sewer, roads, bridges, building structures, geotechnical, the whole gamut of infrastructure products. So it's fun being part of this big international company where we have more of an international reach with our products and to be part of that.
Okay, excellent. Remind me, what does RAM stand for?
That's an interesting story. I think it was Mike, the programmer, that kind of came up with the idea of RAM being this powerful animal, you know, and the imagery of, you know, the ram's head with the horns and stuff. We thought, you know, that'll make like good images and stuff. And we never went with the whole ram as an animal image. But what was interesting was the vice president at Copeland Tanner, who was behind. He was the one that said, yes, let's devote resources, let's write RAM, let's write software, and we will, because it will be a big undertaking, it's not going to just be for use in-house, we're going to do this as a commercial venture. He pointed out something very interesting. His name is Rory Rothschild. His initials are RR. The programmer's initials are, his name is Mike Markovitz. His initials are MM.
I can see where this is going.
I'm Alan Adams. My initials are AA. And so that's not the original intent. I don't think we thought of that. It was just sort of this natural fit.
That worked out really well.
Yeah, it worked out really well.
Well, not only just one initial, but everybody had the same initial for their first and last name.
Everybody had that double initial. That's right.
Wow, that's incredible. So that is a good story. I like that. I never actually knew the story behind it, but yeah.
Yeah.
So, you know, we've obviously that's the history of RAM. Is there anything you could say as far as anything that's new with the software?
Well, we're continually upgrading the software. That never stops. The recessions come and go, and we never slow down. We're not set to projects, whether there's projects out there, there's always something to do in the software to make it better.
Right.
And codes always change. For example, right now we're working on the update to the Canadian still code, implementing that. And we're looking towards AISC 360 22 and AISC 341 22 come out, which will be shortly. And so we'll gear up and do those new codes. In addition, we're looking at things like, you know, how can we bring in cloud computing? And we've introduced some cloud capabilities with our most recent version, and those will continue to improve as we add more capabilities onto the cloud side of things. And I'm excited about that because what we're able to do there, all of Bentley software can take advantage of this cloud stuff, and so it's capabilities that can be shared. So my development group doesn't have to do that capability, and the STAD development group, you know, and RAM, instead we're doing it, you know, Bentley is doing it, and we're all able to feed off of that, and so it extends our ability to give features to our clients, and so there's some, you know, cloud capabilities where you can push your model to the cloud. You can do things like querying on the model, visualization of the model, and things like that, and that's certainly going to expand. And then we look at technical things, nonlinear analysis, things like that. That is a long process that we continue to work on, but it's a long process, and at some point that will become part of the program. And then, of course, what I actually enjoy the most is sort of the simple, just the little time-saving thing. So the engineer's in the software, and he can just, now there's this command that saves him a few seconds, but it's a few seconds of repetitive work that it just saved him. Those are the ones, to me, that are kind of the most fun, because I know that it's making the engineer have a more delightful experience with the software, rather than, I got to do this again and again and again. So
Sure. No, yeah, that's the thing. I mean, we talk about with our Need for Speed initiative. I mean, there's going to be things that change things, big things that change things, but a lot of the time it's little things like that,
right.
And those little things add up.
Yeah.
So as someone who's instrumental in developing the software, what's one of the most satisfying things about that?
Well, when I was a structural engineer, actually doing projects, I used to love to go out on the job site and actually be there and see, I did this, and to actually see, this is what this steel looks like that was on a drawing, and this is what it looks like. And it was so satisfying to point to a project and said, I did that. And I don't get that anymore, and I miss that. That's the biggest thing I miss about structural engineering. But what I have now is knowing that I've had an impact. I've helped engineers all over the country and all over the world with the buildings that they're designing. And now they're more anonymous to me. I drive down and I wonder if that was designed with RAM. And some I know and some I don't. Right. But just the knowledge that I have had a contribution, I've got my fingerprint, so to speak, on all of these buildings that are out there is just so satisfying to me. And even more so when engineers tell me how much they love RAM or how much they appreciate RAM because of how it's helping them work more effectively, more productively on the kinds of things they're doing. So that to me is the biggest reward for what I've done is that kind of feedback. And to be honest, I love this conference because I get to meet so many of these engineers that have used my software on their projects.
No, that has to be immensely satisfying. And like you said, you went from having a hand in designing a project to having a hand in designing the software that designed the project.
Right, that's right.
Just switching gears now, I want to just talk a little bit about where you are. You're in San Diego or near San Diego?
Oceanside, California, which is near San Diego, yes.
I know Oceanside. I always like to ask people what's one of their favorite things about where they live. I'm going to guess the beach, maybe, the weather.
It's the weather and the beach, yes, sure. Yes.
The two kind of go hand in hand.
Yeah.
Are you a fish taco fan?
I love fish tacos.
Do you have like a spot that's like your absolute favorite that you're willing to tell people about?
It's actually a chain called Rubio's.
Oh yeah, I do know. And Rubio's is really good.
It's really, really good. They sort of invented the whole market of fish tacos in Southern California.
Yeah. That's good to know. No, it's
yeah.
I was out there for about a summer, but I remember somebody's like, "Have you ever had a fish taco?" And I said, "No." And they're like, "We'll go to Rubio's," and we went to Rubio's.
Yeah.
And it was really good.
Good choice.
Yeah. Well, El, thank you very much. I really appreciate your time, and congratulations on your award.
Thank you so much.
Thanks a lot.
Thank you.